In the next few minutes, we will try to understand another nice implementation of PPK, which is a signature or e-signature or digital signature. We will also discuss a little bit hashing. Please remember this nice secret envelope and this important wax stamp. We will use it later. Let's start. Our use case is the following. We have a company ABC and we have tax authorities. Company ABC has a tax report to submit. So it is a digital document, Excel spreadsheet maybe, or a Word document. So the company would digitally sign the document, send it to the tax authorities. Tax authorities would receive it, digitally verify the digital signature, and then assume the tax report is okay. So in general, signature is the signing party takes responsibility on the content of the signed document. This is signature, we know it from real life. But what signature is not? It was never meant to hide the content of the document. You saw signed documents before in your life. The content of the document is not hidden. Also, document signature is not a real way to verify that the document is not modified. It could be, forged or modified. Let's see how we implement this scenario. The company ABC would have a private public key pair. We will discuss later where it's coming from. Would take the document, encrypt it using the private key, and send to the tax authority two items, the encrypted document and the public key that is paired with the private key. I wrote your certificate for later discussion. On the receiving side, the tax authority would take the encrypted document and the public key and would decrypt the encrypted document using the public key, would extract the tax report, and that's it. Let's see if this use case or this implementation of the use case answers all our requirements. The information that the receiver gets is an encrypted version of the document and the public key. We'll discuss the certificate later. So in respect of the receiver, the good aspects is that the document, he knows the document is not modified, which is not bad at all. He can guarantee this because, encryption, either symmetric or asymmetric using PPK, whenever you change even one byte of the encrypted message, it will not be able to be decrypted anymore. So in this respect, it's good. Once the tax authority was able to decrypt the document, they know that the document is intact. What is missing? Quote missing, we need to discuss it. First of all, the tax authority got a public key and they don't know really who the sender is. Just a public key. We'll discuss it next. And the other issue, although it's not an issue, is that anyone can read. Why do I say that anyone can read? The company ABC is sending the encrypted version alongside the public key. So technically, any man in the middle could use the public key and decrypt the message. This is what we learned in the PPK video. But if you recall, we just said signature was never, also in real life, signature was never meant to hide the document, only to take responsibility of the document. So this one, anyone can read, is actually not a bad issue. We just accepted when we are discussing about signatures. Also, who is the sender is not really bad, because now we will see how this is being resolved. I guess you already know what is the direction. The most simple understanding of who is the sender is simple. Okay, we get a public key. I'm the tax authority. I will rely on the system of sending. It means if I'm getting an email from company ABC, I know that company ABC has the private key. They were able to encrypt. I was able to decrypt. So I trust the sending system, and I say this is the report. Another level, let's say, of confidentiality on the receiver side, and this is actually what is done, at least in tax authorities that I know, is that it's not that the company is creating the private public key pair and sending the public key each time with the encrypted document. It's the tax authority that is issuing the private public key, sending the private key in a confidential manner to the company, to company ABC, and keeps the public key, the tax authority keeps the public key in its database. And then when the company ABC wish to send the tax report, they don't send anymore the public key with the message, only the encrypted document. This way, somebody, a man in the middle, cannot anymore read the document. So this is an additional layer of trust. On the receiver side, it's easy. They get from ABC, they go to their database, they load the public of the private they gave at the time to ABC, and they are able to decrypt and continue as we discussed. This is another way of getting trust. And there is a third way to getting trust is the following. The tax authority says, look, ABC, it's okay that you digitally sign, but we wish that you send us a certificate and not a public key. A certificate, company ABC, go check my video about certificates. Company ABC would buy a certificate from a certificate authority and would send the certificate instead of the public key. And then the receiver side gets the public key in order to decrypt, but also identity information. And inside the identity information, it would be written, this is company ABC, and this is the third way to get trust. So any of these three ways is okay. It's up to you to decide. At least you know the types of trust. Last issue, I promise this is last page. So far, we didn't discuss the size of the document. And in case the document is very large, for example, the Hollywood, some producer in Hollywood is sending a movie all over the world to many cities digitally, he would sign the movie in order for the cinemas to know that they are showing the correct video, the correct movie. So encrypting, tens or hundreds of gigabytes is not practical. It is very expensive in regard of CPU. So there is a solution for this also. There is a solution for everything. These specifications are is done by very, very smart guys. I appreciate it at least. So what they offered is the following. We don't need to really encrypt the entire document. It's enough that we encrypt a short representation of the document. And to get a short representation of a document of any size, we're using a hash function or hash algorithm. I don't have a YouTube video about hash. If you write me in the description, I will create one. It's quite easy. So the sender, instead of encrypting the entire document, would create the hash of the document and encrypt the hash and not the document. In that case, the sender would send the open document, as we discussed before. This is okay. He would send the encrypted version of the hash, not the hash itself, the encrypted version of the hash, and the public key or the certificate. The receiver, the tax authority, would do the following. They would also hash the document. They would hash the document just as company ABC hashed the document. They will take the result of hashing and save it, and then they would decrypt the hash, the encrypted hash, and would compare the result to the hash they did. If the hashes are identical, they can know that everything is okay. And instead of, this is how we achieved the same goal, but without encrypting the entire document, but only encrypting a representation of the document. Where we are going from now, we saw now PPK usage in signature, digital signature technology. We saw also the PPK video itself. Now you could continue and see the usage of PPK in other interesting technologies. And also in the browser, as part of the HTTPS specification, just note that you don't watch this video before this one. I hope it was clear. If you have some remarks or part of the video are not clear, please write me in the description. And thank you.